Oh my gosh, this is take 3 on this problem. This is a tough problem, but I'm going to do it real fast. I just spent, okay. 2 copies of a 9, 12, 15 triangle have been placed on quadrant 1 so that the legs of one triangle coincide with the positive x and y axes, and the hypotenuse of the second triangle coincides with the positive x-axis as shown. Find the areas of regions 1, 2, and 3. A 9, 12, 15 triangle, hey? There it is again, 9, 12, 15. I wanted to look at it up close, so I did it on GeoGebra like this. The reason I felt this need to look at it this way is because looking at it here, I was stuck by the idea that this is a 30, 60, 90 triangle, and this is a 30, 60, 90 triangle, and if that's 60 there, then that would be 60 here, and then this would be equilateral. And then if this is 9, then this would be 9 too. But if this is 9 also, then it really should be intersecting right at the vertex here and not down from it. And that confused me for a while, and I think I figured it out before I actually redrew it. And my mistake was, do you know already? Let's show you if you don't know. Here it is drawn on this online whiteboard EduCreations. This is in the 60-degree angle. You want to find what angle this is, you go, oh, whatever this angle is, the opposite of it is, opposite leg is 12, the adjacent leg is 9, opposite over adjacent is the tangent, so tangent theta is 12 over 9, so I inverse tan both sides. Inversing tan looks like this. Just to redo that, your calculator, you make sure you're not in radian mode, but in degree mode. You go inverse. Now the tan button has a -1 next to it. That's what you want. You hit inverse tan. It says arctan. That's the same thing as inverse tan. You hit 4 over 3, which is the same as 12 over 9. It's just reduced, and you get 53.13 degrees. So, not a 3690 triangle. I just fell into a trap thinking it looked like one. So, that's kind of how that all helped. So we're left figuring out, okay, how do we find these different regions? Now, hopefully you've already paused it and solved it on your own. I went in a number of different directions. One was, well, what's the area of the whole triangle itself? And that's fairly easy because it's a right triangle. Therefore, the one leg will be the base and the other leg will be the height. And 1/2 base times height is the area of that triangle. And by the way, ignore this triangle. I just don't know GeoGebra well enough to get rid of it. In any case, this triangle has an area then of 1/2 9 times 12. 9 times 12 times 0.5 is 54. So we'll store that away for later. But we still need to figure out, what the problem is asking for is the area of these overlapping regions. So really, it seems to me that this third region is a weird quadrilateral. What's going to be easier is to find these triangular regions. And what's going to be really easy is if I can just find that point, then I'll have base times height, and then I'll have base times height. And so I'll have 2 of my areas. And then maybe I can use subtraction of some kind to find that third area. So let me see how we're going to do this. To find this point, we have a system of equations. And so I need the equations for these 2 lines. This equation I know. It's because I have the intercept and I have 2 points on the line, so I have a slope. The slope is down 12 over 9, which is -4/3. So I can plug that in here. Y equals -4/3 x plus 12. And there it is. And you probably just saw the other equation, but let me show you how I got it. The other equation, to do that other equation, I had to find this point, which is this point. So eventually we want to find this point, but I need to find this point because I need 2 points on the line to know its slope. So what's this point? Well, to do that, I took this triangle and I drew an altitude from the right angle down here to create 2 more right angles. If you remember from geometry, doing that here I am alluding to something. I'd like to explain why, but when you do that, you create all similar triangles. Similar, this one is similar to this one, is similar to the whole darn thing. And it has to do with they all share the same angles. They're all right triangles. And when I draw this altitude, I create, say, well, I create that 53.13 angle that I told you about, and I created a 37. 53 plus 37 is 90. That's where I got 37. And so now I've got a 90, 53. Well, this must be 37. And I've got a 90, 37, and this must be 53. And the whole thing is a 90, 37, 53. So since they all have the same angles, they're similar. So what? Well, if you remember from geometry, similar shapes, like these two guys here, let's say they're similar. They have, if they have congruent angles and proportional corresponding sides. The 2 corresponds with the 6. The 4 corresponds with the 12. 2 is to 6 is 4 is to 12. They make a proportion. 2 to 6 equals 4 to 12. So if I dropped off any of those, you could use the proportionality to solve for it. This would be x, you put it in a proportion, you solve for it. Doing just that, that's where these numbers, this 5.4 and the 7.2 come from. So I started out with, what are you doing? I started out with this, being unknown and this being unknown, but I thought to myself, okay, this is the little leg of the entire big triangle, right? Little leg. The little leg is to the hypotenuse. Little leg is to hypotenuse. Oh, excuse me, I'm sorry. This is the little leg of the little triangle. The little leg is to its hypotenuse. This is the hypotenuse of this little triangle. So little leg is to the hypotenuse as, this is supposed to be an equal sign, is as the little leg of the whole thing is to the hypotenuse of the whole thing. This proportion gave me, solving for it gave me this 5.4 right here. This little leg has to be 5.4 based on solving that proportion. Based on subtraction, this has to be 9.6. Then x becomes the fulcrum point that I can use for another proportion. 5.4 is to x, as x is to 9.6. Little leg is to big leg of this triangle, as little leg is to big leg of this triangle. Obviously not drawn to scale, but so it's 5.4 is to x, as x is to 9.6. Did the work over here. Solving that proportion out, you get cross multiplying, you get x squared equals 5.4 times 9.6, so x squared equals 51.84. Plug that into here and found what's the square root of 51.84, and it's 7.2, so that's where I got 7.2 here for this height. That tells me that this point right here then, if this is 5.4, this is 7.2, then this point right here must be 5.4, 7.2. That means I found a second point on the thing, I plug in slope formula, I'm subtracting 0. This has a slope of 7.2 divided by 5.4. Well, 7.2 divided by 5.4 is 72 divided by 54, and if you the common factor is 18. This is the same as 4 over 3. So 4 over 3 is my slope. My intercept is 0. So the equation is y equals 4/3 x. And now I've got my system of equations. This and this. So to solve a system, I can use substitution or I can use elimination, but since they're in slope-intercept form, I'm going to use substitution. I'm just going to say this, y equals this, y equals this, so this equals this. Put it over here. solve by adding 4/3. Turns out x equals 12 times 3/8 or 36/8 or 4.5. X equals 4.5. Plug it into the other equation, and it turns out y equals 6. So I solved for this point. It's 4.5 comma 6. Okay, what does that mean? That means that this right here is 4.5. So this triangle here has a base of 12 and a height of 4.5. So we'll plug that in here. 12 times 4.5. Then we have to times by 1/2, right? 27. Okay, that triangle has an area of 27. I know, by the way, remember we figured out earlier on the whole thing's 54, so guess what? I think this has got to be 27 as well. Let's check. It's 9 times 7.2. 9 times 7.2. Uh-oh. Oh, it's not 7.2. It's 9 times 6. 7.2 is this point. We want this point here. That's 6. So 9 times 6. Times 1/2. All right, so this region is 27. This region is 27. We've got two regions. What's the last region? Area is 27. Area is 27. Does this area have to be 27 as well? I think this might confuse us a little, so let's look at it over here. I think it does have to be. Because again, this whole deal is 54. 27 of it is covered up, but 27, the rest is not covered up, right? So I think every single region is 27. The regions 1, 2, and 3 are all 27. In area. Checking our answer in the back of the book, we got it right. Let's see if their explanation says, they're saying that region 2 is a triangle with a base 9, this region here. To find its height, we need the coordinates of point A, where the hypotenuse of one triangle intersects the shorter leg of the other triangle. The line containing J has the equation y equals negative 12/9 x plus 12, and the line containing L has the equation y equals 12/9 x. See the second figure 28b for the, so I've got a drawing here explaining why it's 12/9 x. It's basically showing this. I want to show you the drawing. So this is their picture for why this, and it's using the similarity argument without doing all the, it's the geometric mean argument without actually doing all that ratio nonsense. It's just like, hey, look, it's the same angle here that this 9/12 triangle would have if you flipped it. So it figures that it would be 4/3 slope. So solving for the intersection, we get x equals 4.5, y equals 6. We could, of course, continue with 1/2 base times height to find the area is 27, but the coordinates might cause us to pause and observe that 4.56 is the midpoint of the segment connecting 9, 0, and 0, 12. The midpoint of this segment. The segment from the origin to point A, that's again this point, is the median of one of the triangles, and it divides the triangle into two regions of equal area. Thus, all three non-congruent regions have equal area. I'm not sure that makes sense to me. There's an alternate solution. I know I can't get through it before my time wraps up. My name is Mark Dittmer. Thanks for listening.